Okay, do you have any questions from previous class? So we learned about capacitors and inductors. And I talked about the natural response of an RL circuit. Why do we call it the natural response? Because we have a circuit like this. For example, we have an inductor and whatever number of resistors we have over here. It is connected to a power supply. But after some time, for example, for this example, t is equal to 0, we disconnected. What was that?
I'm just saying it goes to a steady state when it is closed. I was saying the switch goes to a steady state when it is.
Yes. Once the switch is open, so this part of the circuit is disconnected from the power supply. So now the inductor, because before inductor saved some energy, stored some energy, now it's going to release without being connected to any power supply. So that's why we call it the natural response. Is that clear? So after that we said, okay, now we want to calculate the relation between I and V, and we know that V is equal to L dI over dt. Now, when there is no power supply, so the current is changing with time, but gradually decreasing its current or voltage. Which one? Decreasing current means decreasing voltage or no? Yes? Okay, it's rinsing. Okay. Now when we have the natural response over there, because of this negative sign we get here for this circuit, we get something like this. So we have this negative sign over here. If we plot it as a function of t, you can see I is decreasing, or you see a decay for I. But what you see before switch was closed. So when for a line time, again for a line time. So we had some current, we call it I naught. When we close the switch, when I open the switch, current is going to decrease but slowly. Okay? So I don't know after some time, you know it now, but I don't want to say it right now. After some time it approaches 0. So the maximum is I naught. If you look at this current before, a little bit before 0, we call it 0 negative, and a little bit after 0, we call it 0 positive. The current is continuous. It means there is no jump in the current. We don't see the sudden change. For example, from 0 it goes to I naught, or from I naught it goes to 0. So continuously it approaches 0. Question? Is that clear? Okay. When we have the natural response, we say the current in the inductor for an RL circuit, the current doesn't jump suddenly. So that's why we say it is continuous. And after that, we use over here T, and I explain why T, because you can see from over here, from this equation, if I put the upper limit of the integral infinity, what would I get over here? What? If I put infinity upper limit of this integral, so I get here infinity, so how much will be the value for I of t? 0. It will be 0. Why? Because we have negative sign over here. 1 over infinity is 0. It doesn't make sense. It means after a line time. So we don't have any static over there because the inductor releases all its energy. That's why we put T over here, because it's a passive component. We put T over here because we want to know in that certain of time how the current changes with time. Is that clear? So from T naught to T, if T naught is our reference point, is our reference time, so we said that our reference time for this circuit T is equal to 0. At time T is equal to 0, we open the switch. So if we say our reference time is 0, we put 0 to T, we get something like this. So for a certain of time, we want to know how our current changes with time. Clear? Question? Okay. So after that we said we calculated energy, power, and then we talked about the time constant. So do you see this guy over here multiplied by t? Because this is negative, and we know that because disconnecting from the power supply, of course it's releasing the energy. That's why we have this negative sign, and there is a decay over there for current. So for this negative sign, you see this R over L. I mentioned over here the reciprocal of time, this ratio, is the time constant. It means L over R is the time constant, not R over L. So here it means we have E raised to the power of T minus T over time. That's why you have here R over L, but the time constant is L over R. Clear? Okay. So we said that after one time constant, what would happen to the inductor? Inductor has begun to release its stored energy. So after one time constant to the resistor. So it releases energy to the resistor. We have a resistor. So for a short time or maybe long time, I don't know, for a certain of time, we have a circuit, even though the circuit is not connected to any power supply. So the current has been reduced to E power to -1, or approximately we say 0.37. Or sometimes you hear that 37% of its initial value. This is because of E power to -1. Is that clear? Question? Okay. And again here I wrote that a line time means a line time the circuit to reach its steady state value. Example? I didn't go through this example. Did I? No. Okay. Again, you see the circuit like this. So you always, it's not set in this, you don't see an example or the problem. So, okay, now it is the natural response, find the natural response. You have to know it. When you see something like this, and the question says, the switch in the circuit shown below has been closed for a long time. So this was closed for a long time. So we had this circuit. So how much is the current going through the inductor? How much?
Zero.
0 when the switch is closed for a long time. How much current going through the inductor? 20 amps. Yes. Why 20 amps? Do you want me to explain?
No, I was just mixing things.
Okay. So this is closed for a long time. So we know that when inductor stays in a circuit, which we have, the power supply is constant. So there is no di over dt. So after a long time, inductor acts as a short circuit. So when we have a short circuit over here, all the current goes inside this one. So there is no resistor over here, no over here, here, and here. So we have a circuit like this. So how much is the maximum current going through how much is the current going through the inductor after a long time? 20 amps. Why? Because of this value. So we say at t is equal to 0 minus. Why 0 minus? Before the switch is open. So we know that V voltage across this inductor is 0, and IL at 0 minus is 20 amps. And I already explained that before we close the switch, and after we open the switch, IL 0 minus is equal to IL 0 plus and 20 amps. Because there is no jumping, there is no sudden change in the current flowing in the inductor. So we have over here 20 amps, and now at time t equal to 0, it is open. So when it is open, we have just this part of the circuit. So this part of the circuit we have, so you look for equivalent resistance. What is the equivalent resistance in this circuit? You have two resistors in parallel. What are those resistors? 40 ohms and 10 ohms, and they are in series with this one, 2 ohms. So 2 plus 10 multiplied by 40 over 10 plus 40. So you should get something like this, 10 ohms. You will get 10 ohms. So how do you calculate R, the time constant? N over R, which are this equivalent R? Is that clear? So you have L, how much is L? 2 Henries. And how much is R? 10 ohms. So you get 0.2 seconds. And we know I L of t is I naught e raised to minus R over L times t, or t over tau. Okay, we know the value for I naught, 20. We know value for R over L and t. So we get this equation for I L of t. Questions? The next part, find I naught of t. What is I naught? Is here. The current which flows in this resistor, 40 ohm resistor. How do you calculate I naught of t? Voltage across this resistor equal to voltage across this resistor. How do you calculate voltage across this resistor? Ohm's law, 40 times I naught. But you see the current for this direction, another current is in this direction, and one current is into the knob. So this voltage is equal to negative of the other one because the direction of the currents. Is that clear? That's why I put minus 40 over here. So minus 40 times I naught is equal to 10 times this current. I 10 ohms. So what is I 10 ohms? I naught plus I L. So from here, you can find the relation between I naught and I L. So 10 over 50 times minus IL. You already have the value for IL, not the value, the function for IL. So we just substitute this one into this, you will get this. Okay, when the switch is open, so this part is disconnected, so we don't have it anymore. So when it's closed for a long time, so we have a short circuit because when we have a constant power supply and the inductor stays in that circuit for a long time, it acts as a short circuit. So once it is short circuit, all the current will go for this one, so we actually don't have this resistance. Okay, any other question? Okay, for the third part, find V naught of t or t greater than 0. So what is V naught? Voltage across this 40 ohm resistor. So we have I naught, we have the value for this resistor, there is a resistance for this resistor. So Ohm's law, V naught of t is equal to R times I naught of t. So you have 40 times I naught, you will get this one. That is and for the last part, find the percentage of the total energy stored in the 2 Henry's inductor that is dissipated in the 10 resistor. So you see this circuit over here. It has some stored energy. When the switch is open, it releases some of its energy into it through this resistor, some into this resistor, and some into this resistor. But the question wants us to find the dissipated energy in the 10 ohms resistor. it means this one. When you see questions like this, first you look for power. So how much is power for this resistor? Is V naught square over R. Why V naught square? Because these two resistors are in parallel with each other. So the voltage across this one is equal to this one. So V naught square over R, which is 10, you get something like this. This is for power. So the question wants us to find the energy. So the energy is 0 to infinity of this one. So can you tell me why I put infinity over here? Yes. No. You don't see anywhere in the question it is closed again. It is open at 2 times 10 and that's it. One is infinity, one more time. So it's open. Okay, so what is infinity? But before we said t, right? We said interval from 0 to t, not infinity. Why this time infinity? Thanks. What is the question? What are you looking for? Of total energy stored in the two-hand inductor that is dissipated in 10 ohms resistance. It means now the inductor releases all its energy. When it releases all its energy, it means no more energy in the circuit. No more circuit. All is dissipated into resistors, those 3 resistors. One of these resistors is 10 ohm. So we say infinity here is a little bit different from what we know from the math. Infinity over here means for a long time. So we have to wait for a long time so that the inductor releases all its energy, because we are looking for the total energy, right? So that's why we put infinity over here. Infinity over here means long time. Is that clear? Yes? Okay, so now we have infinity over here. We have this one, value for power. From 0 to infinity, why 0? Because at time 0, we open the switch. So we get this value over here, 256, sure, 256. So what is the maximum energy the inductor has?